Hi there, this is another year 12 video, and you'll notice it says year 13. That's because well, I've basically started some work on some of the year 13 topics, work that I think will be easier for you perhaps to understand than some others. So that's why we've started this year 13 topic. You'll notice it's on functions and what are called mappings. Mappings is the posh name for those function diagrams you used to draw, and I've put on this book, on this slide here, you'll notice, basically got an input, numbers, a posh name, domain, we'll come back to that word later on, and when you chuck 2 into this function, this mapping, whatever you want to call it, 4 pops out, and the numbers that pop out are called the range. The range are the numbers that come out of the function, and the domain are the numbers that are allowed to go into the function. And God knows what this is. This could have been a doubling function, but you look at the other numbers, and to be honest, I don't care what they are. But you'll notice this one has got one number goes in, one number comes out, which seems obvious. Over here, for instance, 2 goes in, 4 goes out, 3 goes in, 1 comes out. They look very similar functions. It seems like this has got another number that goes into it, whereas figure 3. It's slightly different because 1, it seems, can produce 2 numbers. So you get this idea that some functions are different from others. So let's have a look at a few anyway. For a starter, I just want you to have a look at some of these. It's a substitution exercise, really. I'll tell you what y is. Y is x squared, and you have to work out what y is when x is 2. So obviously you chuck 2 in, you get 4. You chuck minus 2 in, and the interesting thing about that, you get 4 again. And then it's going backwards. And what is x? So we'll work out what x is when y is 4 and y is minus 4. Now some of these don't have solutions, and so I want you to have a look at them and see what you have for questions 1, 2 and 3. I'll just put the answers up for you to have a look at, and hopefully you've done these by the time you've pressed pause and restarted it again. And these are my answers, and you'll notice there on a couple of occasions we get slight weird answers. This one I've said there's no real solutions. That was one I was actually doing, and it's because I said x squared effectively had to be minus 4, and you never get x squared equal to minus 4, because whenever you square a number it's more than 0. Now this is the posh way of writing it. X belongs to the real numbers. So if x belongs to the real numbers, then x squared must be greater than 0. And of course it's not greater than 0, therefore there's no real solutions. B, as I've written here, I've written undefined. That basically means I suspect that's a division by 0. And here's another one which is no real solutions, and I can't remember what the question is. I bet it's the same thing. Let's just go back to it. Yeah, it looks like it is a square root of a negative number, and I probably should have written the same thing underneath it, like there. Oh, there I did. There you are. So if that's the case, let's have a look at some function notation. Function notation really is just a posh way to write an expression. So you get these equivalent ways of writing it. What you've seen loads of in the past is you say y equals 2x minus 1. Just be aware, though, I could write a function. Now, usually it's f of x. And this one says h of x. I could have a g of x or k of x. So the h, the f, the g, whatever it is, doesn't matter. It's just the fact that some function, which I've called h, is equal to 2x minus 1. And sometimes you even get daft ones like this. This is, you'd say this, x is such that x becomes 2x minus 1. X is such that x goes to 2x minus 1. So in other words, if I put this number in, then what pops out of my function is 2x minus 1. If I put 4 in, 2 4s are 8, minus 1 is 7. So this is just a different ways of writing the same thing. So here's one function, f of x is 2x squared plus 3. Here's another function, g of x is sine x. They're just functions. It's just a name for them. So back to domain and range. These are the domain, the numbers that can go into this function. So I'm saying to you in a bit, I'm going to give you some numbers which can go into this function, and the range are the numbers that come out of the function. If I can put all numbers into a domain, then lots of numbers can come out. But if I only have selected numbers that can go in, only selected answers can come out. So I'm now going to give you some numbers in here, and I've suggested minus 1, 0, 15 and 2.1, just any number. And with this function that we saw just now, f of x equals 2x minus 1, if If I put the -1 in, I will get -2, minus another one, -3. And all of these produce an outcome. And that outcome is called that they are all part of the range of this function. So they're numbers that go in the domain, numbers that come out the range. Now consider this then. So we're getting now into the nitty-gritty of what the difference between these things are. Now I mentioned mappings before. All of these things are actually mappings. But let's just look at the graph of y equals x cubed plus 1. Y equals x cubed plus 1, you'll notice whatever number I start with, there's my pen over there. So if I have a number, for instance, it looks like about 1.1, if I put that into my function, my graph tells me it'll be roughly there. That comes out, 2.6, whatever it is. And if I pick any other number, so that number there, what number comes out? If I pick this number here, badly drawn, but you get the idea, very badly drawn, one number comes out. So all of these, one number goes in, one number comes out. Whereas this graph here, y equals sine x, I put a number in, one number comes out. But it's not quite so easy, because if I put a different number in, I get the same number that comes out. Now that doesn't happen over here. Even though these look very similar, they're all slightly different as it goes up. And so if I was to try to get this number here, there's no other way of getting, if I draw that line going across, there's no way I'm going to get the same number as I got from 1.1 with any other number. Whereas on this one, that looks like 0.7, seems I can get that with this number and on this one. And on this one. And on this one. And so for this reason, there's some examples on there, and on this one, look at that, I've chose very similar ones here. So for this reason that we call this mapping a one-to-one mapping. One number goes in, one number comes out. Whereas this is many-to-one mapping. It could be only two, but we still call it a many-to-one mapping. Lots of things produce one answer, the same answer. Let's have a look at these. These are also, it says one-to-one mapping. So one number goes in, one number comes out. One number goes in, one number comes out. One number in, one number out. These are all one-to-one mappings. These now are many-to-one mappings. So this is the second type. One number in, one number out. But there's another number in, the same number out. This is why this is a many-to-one mapping. In actual fact, that many is two. It doesn't matter, it's many-to-one mapping. At one point, of course, this point down here, it's actually just one number in, one number out, but that doesn't matter. But broadly speaking, we call that a many-to-one mapping. There we are. So this one, the x cubed graph, there's one point, there's another point. So this is, and of course this point here, right here as well. So this has got 3 points which will give me the same answer. So this is a many-to-one. That one is just one-to-one. You're not going to get that any other way, but generally it's called a many-to-one. And we have a definition. The word function actually is very specific. It's not all of these. A function must be either one-to-one or many-to-one. It can't be anything else. And you might be thinking, well, he's not showing me anything else. There's only these two types. But there are actually other types of mapping which are neither one-to-one or many-to-one. So I suppose we need to see that. So here's, I've got a graph of, now it's quite a complicated graph. I've written y equals plus or minus x, the square root of x minus 1. It actually comes from, if I was to square root both sides, y squared equals then, well, the square root's moved over, x minus 1. So if I move that square root over, the plus or minus doesn't matter if I square this side effectively. And so it's not such a nice graph, but that's the graph I'm going to look at, and that's the equation of y equals plus or minus the square root of x minus 1, or the y squared equals x minus 1. And what you'll notice on this one, this is not a function. We call it a one-to-many mapping. And I suppose I should draw it before I go on to that. Let me just draw it. So this point here, 3 for instance, actually I can go both ways. So this has got 1 point, and it gives me many answers. It gives me this answer and this answer. Again, it's a 1-to-2 mapping, really. But the critical thing here, this is not called a function. A mapping which is one-to-one or many-to-one is a function, but this is a one-to-many, so this is not a function. And here's another example, x squared plus y squared equals 16. You may remember that from our work on circles earlier in the year. It's a circle of radius 4. And the great thing about this function is, here, take this point, for instance. I can go up here and I can go down here. So one point goes to many places. And I can take this point, not very well done, that one there goes to there, and this one here goes to there. So we can think of this as many places go to one place as well. So to get around the fact that it kind of goes in both directions, we call it a many-to-many mapping. Again, distinguish in your mind this type and this type are not functions. Now, one way of thinking about this is in terms of lines, a vertical line and horizontal lines. And if you think about what the graph looks like, you might be able to then decide whether or not it's a function or not. Now, remember our definition of a function. Let's go back. A function is one-to-one. Where is it? It's up here somewhere. Where's my pen there? A function has to be either one-to-one or many-to-one. These weren't like that. And so if I draw a horizontal line going across and I hit more than one place, yep, then we call that a many-to-one mapping. That's another way of thinking of it. Gets more than one place. If I draw a vertical line and it hits more than one place, yep, hits one, hits two. So this is not a function. So our definition of not a function is it can't hit more than one place when I draw those lines. Whether it's a one-to-one or a one-to-many or a many-to-many, you just don't know at this stage, or other than by looking at the picture. But it could be either of those two. If it draws a vertical line and hit more than one place, the critical thing is not a function. And if it does hit both, so I draw that and you can see, yep, and so it hits two places, and I draw myself a vertical line as well. Yep, hits both. Well, that makes it, I suppose. Now I know that's a many-to-many. So you're meant to answer some questions based on this. Now, it's in the exercise 2A from the Year 13 book. You'll get an exercise in Moodle, which is obviously from the Year 13 book. It's going to be a step up. Some of these questions are going to be a little bit harder now. So if you get stuck, ask. But this is not particularly algebraic topic. It's quite a kind of get your head around it topic, what the pictures and what everything is meant to imply. But any problems, come back to us. And other than that, thank you very much.